Hello, I've been playing around with these little laser transmitter and receiver modules and just experimenting to see how effective they are at sending data over distance. And surprisingly, they're very effective actually for the price. So what we have here is basically a laser pointer piece at the front. So that's sort of a lens bit on there. And there's just three inputs. There's a ground and a 5 volts and then a signal. So that's just a digital on-off signal. And there's not much more to it. You can see there's an SMD resistor by the pins. And there's another SMD resistor stuck on the side there. And the other side is just a big lump of solder. And that's it. There's nothing on the bottom. You can probably see that the traces there actually, if I hold this properly, there's 4 pins, but there's only 2 connections. So 2 of those pins are connected to each other. So that's it. It's basically just an on-off switch. And at the other end, it's a little bit more involved. There's some resistors and a cap on there, but not much more to it. And this little thing up the top will detect when the laser is pointing at it, and it will make this pin here, which is labeled out, go high or low, depending on whether it's being pointed at by the laser or not. So it's extremely simple. It's almost just a direct replacement for a wire. And this little detector bit on the top seems to have a front and a back. So I think that's the front with a slightly rounded looking piece of plastic on the front. And this is what I'm going to call the back. And I noticed that at close range it's actually more effective if you point the laser at the back, because the whole piece of plastic sort of lights up and it seems to make its way into the detector on the front just as effectively. And in fact, at close range, if you point it at the front and right in the middle, it doesn't work as well, which is a bit strange. I don't know why. Like if it was radio signals, I could understand maybe it was some sort of a saturation issue, but I don't think light turning on and off would do that. But strange. Anyway, so at longer distances, I found that if you don't use the front of it, you won't get any reception at all. So using the back at longer distances when the light is weaker, it doesn't actually work very well at all. So anyway, front and back, something to keep in mind. So this is a sort of a continuation of a video that I made yesterday. And in yesterday's video, I was outputting some audio from an Arduino. So that's what I'm going to try doing here, sending some audio across this laser link. And in yesterday's video, I was using this rather involved way of getting digital audio to come out as an analog signal. And thanks to some people in the comments from yesterday's video, I've been pointed to a much simpler way to do this, and it actually sounds better as well. We can't quite get the 14.4 kilohertz sound that I was trying to get yesterday. We can only get 8 kilohertz sound, but it still sounds pretty decent. And as another nice side effect, it comes out much louder in my headphones. So I'm going to use my headphones to do this instead of the computer speakers. And we actually get a better result all around. So first, before I get to hooking these up, because it's really simple, there's nothing to it for those, I'll just show you what I'm using to output the sound today as opposed to yesterday. It's much simpler. That's the whole thing there. Just two lines coming out to my headphones, and that's all. So I was pointed to this page here. Oh, this is the modules. This is where I got them from on Banggood. So this is again 3 pieces. So they're like $1, $1.12 or whatever for each one. Very cheap. And the receiver, that's 2 pieces for $3.20. So it's like $2, $2.50 or something for a receiver transmitter pair. Very, very cheap. So that's why I was surprised that they work so well. Anyway, this is the program that I am going to be using today. So thank you to the person who commented on this, pointed me to this. And like it says, it works with 8 kilohertz audio and works quite well. So I have this already on the Arduino that I have in front of me, so I'll just show you what this program does if you were to take this and copy and paste it into your Arduino IDE and run it. So that's this one. This one here. Oh, well, it's already on the Arduino, isn't it? So let's just run it. So I'll just reset the Arduino. So that noise you hear is coming from this array of bytes here. So it's not reading from an SD card or anything. That's why it's a very short sound. We can only have a length of, what is this, 10,000 bytes in total. So they're all manually, I guess you could say, placed in this array to be read from. And I'll just look at one point in the main program where it's using this. I'm not going to get into the details of how this works, but it's using an interrupt to trigger a change in, it's making pin, or in my case I'm using the pin 11 as the output pin, and it's just making that go high or low at a specific time depending on the value of the bytes that it's reading from that array. So it's using the timer values here to do that. So this line here, I'm going to come back and change this line later on, but basically all this is doing is it's setting that value of the timer to one of the bytes that was in the array, and then we increment the array index that we're looking at. So I'm going to come back and change that later when I read my data from the laser receiver. But that's how it works. So I haven't changed anything at this point. So before we try using these, let's just try getting data from another Arduino with just a simple wire, because like I say, these things here are basically a direct replacement for a wire. So very simple to use. So let me just get this set up with a wire to connect it to the other one. Alright, so I have my two Arduinos set up now. This is the one that we were looking at just before that's connected to the headphones. This one over here is reading in some data from an SD card, and there's a wave file on there, 8-bit 14.4 kilohertz wave file, so it's being read in. And we're just going to output that on the serial TX line from this Arduino, and we're going to read it into the serial RX line on this Arduino and put it out to the headphones. So just have a look at the source code for these. The sending Arduino is this one here, and this is the example from, I think it's included with the Arduino IDE, and it's one of the examples called dump file, and I'm calling this dump file to serial just to give it a different name so that I know what I'm looking at when I look at my menu. But the only thing I've changed in here is I set the chip select pin to 10 because that's what I'm connected it to. I changed the serial speed to 115K instead of the 9600 that it is in the example. I changed the name of the file that we're going to dump to the name of my wave file, and that's it. That's the only thing I've changed. So we're just reading out a file and dumping it to serial, but importantly it needs to be at a specific speed. And on the receiving side, I'm using the example that we just saw that played the Mac OS startup sound just before, and I've only made a few changes in here as well. So I added this global variable, so we now have a global variable called the byte, and this is going to store just one byte of data as we read it in from serial. So if we go right down the bottom, we'll see I added serial begin at 115K to match the sending side, and in the main loop I added this so that we check if there's any available information coming in from the serial connection, and if there is, we set the byte to that value that we read in. So this is going to overwrite the value of the byte many times. That might look a little bit pointless, but remember that the byte is, well, I shouldn't say remember that because I haven't showed you yet, but remember that we have this interrupt here, and this is going to be called at 8 kilohertz to load the next sample. So in the example as it stands, or if you copy it from the website, it'll be loading in a byte from this big array here. But instead of doing that, we want to do this. We want to set the sample to the byte, whatever that happened to be, the last value that we read in. So what's going to happen here is we're sending data at 115 kilobits per second. But we're only going to be playing it at 8 kilohertz. So it's sort of effectively downsampling the sound for us automatically. And it actually sounds quite good. So let's have a listen to it. So to connect these two Arduinos, we need a ground to ground wire, and then we need this one here. So I've got this plugged into TX, and this one over here is plugged into, will be in a second, plugged into RX. And I'll just start the song again because this bit at the beginning lets you sort of hear the pace of the sound better. So without having to mess around with slowing things down or speeding things up, it's already playing at almost the right rate. And that's simply because the sound file that we're reading out is storing the sound at 115 kilobits or 14,400 bytes per second. That's the sound format of the file that it's saved on here, which is the same speed as the serial connection that we're sending it through. So in actual fact, the sound that we're hearing is a little bit slower than the original, and I would suspect that that's just because of the slight overhead that we have in the program as it runs. So a little bit noisy now. Just in a slight overhead and things like this loop and stuff. But it's pretty close to the original speed, so that's kind of a nice side effect. Right, so now to use these little laser thingies, all we're going to do is replace this line. Oh, actually we don't need this line either. So I'm going to take these two lines away that connect the two Arduinos, and I'm going to plug my transmitter. So it's this guy. He's going to be plugged into ground and 5 volts. I wonder if it might work on 3 volts. I haven't really checked it. And then the signal wire is going to be plugged into the TX on this one. And that should see us sending some information. So of course you can't see this switching on and off, but ow, just kidding. You can't see this switching on and off, but it is. So on the receiving side, I'm going to plug in this guy, and he goes into, again, ground, and I found that this receiver works better on 3.3 volts, although it says it should work with both. So I'm just going to use 3.3 volts. Oops. And it has a nice little light that shows up just to let you know that it's running. And then the signal goes into the RX pin on this side. So the connection is made now, and now all we need to do is point the laser in the right place and hold it still. So I'm pointing at the back here, and like I say, at close range it seems to work better pointing at the back of the detector. If I point it at the front, you'll see if I point it directly at the middle of the detector on the front, it sort of goes all crackly. So that's pointed right at the middle. If I point it just on the edge, it might be a bit hard to tell in the video, but I'm not actually the beam is not directly pointing at the detector at all there. It's sort of just clipping the edge of it. So it seems like at close range it's too strong to point it directly at the front. There we go. So it's not actually pointing at it there, right? Now it's right in the middle. Seems like it's too strong. So if we point at the back, we can point it right in the middle, no problem. And it's actually very good. I wonder if it's detecting the reflection from my fingers there. Is that what it is? Oh, that's what it is. Hang on, restart song. Oh, that's all it was. It was just my fingers. So there's enough light coming back from my fingers behind it for it to detect that. Oh, that's cool. So it's quite sensitive. Yeah. Anyway, enough of that. So you're probably wondering, as I was, over what kind of distance is this still effective? So I took it outside for a test this evening, and here are the results. Anyway, so we have this laser thingy pointing out there, and you might be able to see it, but it's pointing at the side of that watering trough over there. I'm just turning it off and on. Anyway, that's probably about 50 meters away. Yeah, so I'm just going to walk out there and hopefully we can get some audio going. Where are we? No audio. Why not? Oh, it's probably finished. Okay, so we've only got four and a half minutes to do this because the song stops after 4.5 minutes. Try it again. Okay, so hopefully you could hear that. And let's go to the fence. The fence is about halfway. Where is it? Oh, there it is. Oh yeah. It's actually easier to have it focused there too because the beam is wider. Let's see. So it's about, what is that? Almost 10 centimeters square. Yep. No problem. Although it doesn't pick it up on that side. Only on the front. Or back, whatever that is. Must be the front. Oh shit, I think this is the end of the song. Yeah. Anyway, I'll tilt this up a little bit further so that it's pointing over the top of the watering trough, and I'll just go way out there and see how far I can get. We're almost at the tractor, but so I was going to use this tractor as a distance measuring because this tractor is on Google Maps, so we can measure the distance, but unfortunately it's pointing at the ground, so oh cool, I can see it. Oh, look at that. Okay, so it should be here somewhere. Oh, here it is. This way? Yep. Getting weak. Well, that's not bad. We're right at the tractor. Okay, so I'll measure whatever distance that is on Google Maps, and that will be a pretty good Pretty good distance for it so far. It's breaking up a bit though, hopefully you can hear that. So there you go, not too bad for $2.60 worth of parts, eh? But to be honest, it's not very useful for something like that. You have to line things up perfectly, and the kind of data that you're sending over has to be the kind of data that doesn't matter being dropped out a little bit. So audio is quite good for that, because you don't need to get all of the audio to hear the audio enough. But as far as Arduino projects go, it's probably a bit more useful for something like this, to detect when something goes between 2 points, like a burglar alarm or something like that. I don't actually have any intention to use this for anything, but for $2.60 I thought it would be interesting to play around with them, so that's what I've been doing. Anyway, that's going to do it for this video. Thanks for watching, and I'll see you next time.